Good morning or good afternoon, Tigers. This quizette this week has a lot of different things to it. So even though the questions look the same, for instance, for number 1, they're asking for different things every day. Same with number 2 and same with number 3. So make sure that you read the questions carefully. As always, please write your last name, comma, first name, the date, and your class color. If you have not yet done this, please pause the video and hit play when you are done writing your last name, comma, first name, the date, and your class color. Looking at number 1, it says GI and JL are parallel lines. So here's G, and here's I, here's J, and here's L. So these two lines are parallel to each other. This line intersecting them is called a transversal. So when you have 3 lines like this, they're called a transversal. The question asked, which angles are alternate interior angles? So alternate interior angles is something I have not taught you. So it's fairly new. So if you look at our transversal, there are 2 angles outside, 2 angles inside, 2 angles inside, and 2 angles outside. So the outside of the transversal is considered the exterior of the transversal. So this is the exterior right here. This is the exterior. And the inside is the interior. So when it's asking you which angles are alternate interior angles. So when you think of the word alternate or alternate, you think of something that trades. So sometimes it's with this person, sometimes it's with that person. It just alternates. Kind of like sometimes when I collect papers, sometimes I pick person A, person B, so it alternates. It changes. So if we look at the interior, we have this angle right here, which is GHK, and then we have IHK, and then we have LKH and JKH. So we are looking for alternate interior angles. So if you look at LKH, the alternate interior angle would be GHK, because this obtuse angle is the same measure as this obtuse angle. So those are alternates of each other. So you could say angle GHK and angle LKH are, I'm just going to abbreviate it, alternate interior angles, are AIA, which means alternate interior angles. There's another pair of alternate interior angles. If you look here, there's an acute angle right here, which is angle IHK. And there's another acute interior angle, which is angle JKH. JKH. And it is an alternate interior angle to IHK. So we'll say those angles are alternate interior angles. So I know this seems really difficult, but the other questions are not going to be as complicated. So if you look at number 1 for Wednesday, it's asking you for corresponding angles. Remember, corresponding angles are talking about the outer angles, so the exterior angles. Which angles are corresponding? If you look here, ACB corresponds to CFE. So I'm not going to write that down because that's going to be yours to do on Wednesday. Number 2 on Monday. The radius of a circle is 6 centimeters. What is the circumference? So again, this is something new. You have not seen this before. But the circumference of a circle is in regards to the outside. So it's kind of like perimeter. If you think of perimeter, you think of the outside. So circumference is kind of like the crust. So like if this circle were a pizza, we're just talking about the crust, the outside. So the circumference is the outside. but we're only given one piece of information, which is the radius, which is like half of maybe the side of a slice if we're thinking about a pizza. So it's asking us what's the circumference, so what's like the perimeter. Here's the equation. Circumference, or C, equals 2 pi r. So I know you guys are thinking, Miss Molina, this symbol right here is not pi. It doesn't look like pi. I'm thinking of apple pie, pumpkin pie, but we call this symbol pi because the shape of pi is in regards to a circle. So when we think of a circle, apparently mathematicians think of a certain type of pi. Nevertheless, this symbol means pi. And this symbol is drawn like this. It's two lines and a squiggle on top of those lines. We can say that pi equals 3.14. So we're looking for the circumference, so we don't know what C is. We're going to bring down our 2. Pi is 3.14, so times 3.14. And what's our radius? 6 centimeters, or we can just say 6. So 2 times 3.4 times 6. So I'm just going to multiply these two. 2 times 6 is 12 times 3.14. It doesn't matter what order you multiply them in. Well, you're going to multiply them anyways. So this is the part some of you are going to like. Please use a calculator for this. I don't even want you doing it by hand because chances are some of you will mess it up. So please input that into a calculator. You have a calculator in your Chromebook. Multiply 12 times 3.14 and put your answer down here. Now if you look at number 2 for Tuesday, it says the radius of the circle is 3 feet. What is the circumference? So automatically just write right now. Circumference equals 2 pi r, and then write pi equals 3.14. So it's the same thing. Now let's look at number 3. Number 3, for some of you, it might look a little frightening. Like, I don't even know where to begin with this, right? However, every compound figure, so this is considered a compound figure because there's 2 parts to it. It looks like there's 2 rectangles here almost. So if I draw a line right here, we can literally just focus on this shape, this rectangle right here. We already know the area of a rectangle is length times width. So we can find the area of this black box, and then we can find the area of this rectangle over here. So here would be the length, and here would be the width of this small rectangle. So the area of this rectangle would be 6, because 3 times 2 is 6. So our area of that small one. So let's look at this black one. We have a length of 11 and a width of 5. So 11 times 5 is 55. So now let's add these two. We have 55 plus 6. So then what's the area of the entire figure? 61 yards. So this compound figure can be broken down into 2 rectangles. Always try to simplify compound figures. So if you look at number 3 for Tuesday, you can easily turn that into a compound figure as well. Try to do it right now before I draw it. See where you can draw 2 shapes where you can easily find the area and just add them together. Right there. So you have a square. I'm sorry. It's not really a square. It looks like a square, but it's not. So this is where it could get a little confusing for some of you. Because you guys might think, oh, here's 5 and here's 6, so I'm going to multiply those two together. But if you look at this, 5 is the length of only part of this side. We're looking at this 7. This is the correct measurement of the side because it's the full side. Just like we can't say, oh, this side is 10, so it's 10 times 7. No, we have to look at the full correct side. So if you look here, the width of this rectangle is 6, and the length, or you could say that this is the width and this is the length, doesn't really matter. So we'll say that the side is actually 7. We can't say it's 5 because then we would have to have a square that's like this. See that? Because 5 only goes to there. Hopefully I'm not confusing some of you. So for this rectangle, it would be 7 times 6. And for this little rectangle over here, it would be 4 times 2, which is 8. And you guys can do the rest tomorrow. I'm getting a little ahead of myself. Well, I hope this helped you guys. When you're done, this is what I want you to do. I want you to go to my website, click on the quizzette so you can get the electronic version. Then I want you to click on this iExcel practice right here, this link where it says you're going to go to geometry and then click on area of compound figures. If you click on this link, you will go directly to it. All right, Tigers, have a good day.